All right, Module 6, Lesson 2, Displaying a Data Distribution. And in this case, we'll be looking at a dot plot. So we're going to have some data, and we're going to find a way to display this as a dot plot so that we can start to look at the data and draw some conclusions. All right, so given a set of data, I can construct a dot or a line plot. You'll actually do a little bit more of that in the next lesson, but you're going to see what they look like, and most of you will figure out how to do it just by watching. And we're going to describe the distribution of the points in terms of center and variability. So we're going to look at the idea of what is the center of a data set, and we're going to look at how much variability is there within the data set. All right, these 4 steps should look very familiar. We saw them in Lesson 1. Today we're going to be looking at steps 3 and 4. We are going to summarize data with a dot plot, and we're going to use a dot plot to answer questions about a set of data. So we're looking at steps 3 and 4. All right, Mia, a 6th grader at Roosevelt Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. So in other words, while they're resting, their heart rate is lower. She wondered about her own heart rate and how it would compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of students in my 6th grade class? So we are collecting the data, what is their heart rate, and we expect variability because we have all the students in the class who will be participating. Heart rates are expressed as beats per minute, or BPM. Mia knew her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. With the teacher's help, the other 6th graders in her class found their heart rates and reported them to Mia. The following numbers are the resting heart rates in beats per minute for the 22 other students in Mia's class. Now it's important to recognize that Mia's is not on this list. These are her 22 classmates. So there is our real-life situation, and now we're going to work with this a little bit. So to learn about the heart rates, a good place to start is to make a graph of the data. We have all of these numbers, and they're just kind of garbled up here on the piece of paper. We're going to be looking for a way to use this piece of information. We're going to try and turn this into a graph so we can look at it and say, what does it really tell me? Mia noticed there were many different heart rates. She decided to make a dot plot. So one way that we can represent data is using dot plots to show the different heart rates. We're going to help Mia construct a dot plot of her classmates' heart rates by drawing a number line starting at 78 and continue to 92. Dot plots are also known as line plots because what we do is we actually construct a number line. And instead of starting at 0, we take a look at our data and we decide where we need to have our line go from. Now they've said start at 78 and go to 92. If I take a look at the data here, I've got a 79. So 79 is my lowest number, so by putting a 78 here, I'm starting at nothing. And it says go up to 92. Here's a 90. So I've got 78, which is going to be a little bit below, and I've got 92, which is going to be a little bit above the highest. And on my number line, I am going to count each one of the numbers. Or what I could do is I could count by 2s. 78, 80, 82, 84, 86, 88, and 90. Now, by counting by 2s, I have left a spot for the numbers that are in between. Now, for a dot plot, I would actually go and I would put a dot above each one of these numbers. So it's kind of like tally marks. I'm keeping track of how many times I have a number. So I have 89, and I would put, there we go, 89. Oh my goodness. 88. There we go. There's 89, and there's a dot for 89. And I'd find 87, and I'd put a dot. And I'd find 85, and I'd put a dot. I'd find 84 and I'd put a dot. I'd find 90 and put a dot. I'd find 79 and put a dot. I'd find 83 and put a dot. I'd find 85 again, and I'd put a second dot above it. I've had 285, so I've got 2 dots above it. And I would continue this for all of the data points. Now, to move this lesson along, I'm going to go to the next slide where you can see a finished dot plot. So we have our dot plot here, and before we go any farther or any deeper, let's just take a moment here and look at this and say, what do we see? Is there anything that we notice? If someone asked you to describe the information, what would you say? If somebody said, where is the center of this information? Where is the center of this data? What would you say? How would you describe the variability or the variety in this data set? This would be a great time to pause the video, think about those questions, and then continue. Well, the first thing is, what do we notice about the heart rates of the 6th graders? Well, there's a couple of different things that I notice. The first, the heart rates are going to range from 79 to 90. So I have this description here of kind of where the numbers fit. I could look and say 83. 83 was the most common answer. There were more students who had a heart rate of 83 BPM than any other number. I could make the observation that none of the students had a heart rate of 80. So there are lots of different observations that I can make as I look at this data. The second question is, what about the center? How would you describe the center of this data set? Well, 83 is kind of like the center because it's the spot that came up the most. It is the number or response that came up more than any other number, and we'll talk about that a little bit later. As we get a little bit farther in the module, I could say the center is somewhere kind of around 84 because most everything is kind of right here. So maybe 84, 85. I mean, this kind of looks like the very middle here. So there are a few different ways that I can look at and describe the center of the data. Now they use the word here spread, variability. What is the data spread over? What is the variability? Well, we could look and say, well, most of the heart rates fit in the range of 82 to 86. We could describe it as the data goes from 79 to 90. Once again, I'm just trying to come up with some way to describe what I'm seeing. Okay, now we're going to just use the dot plot to answer a few very basic questions here. For example, what was the heart rate for the student with the lowest heart rate? You'd want to pause the video, answer the question, and then compare. And hopefully you came up with an answer of 79 BPM. Right here is my lowest heart rate. Exercise 2, what was the heart rate for the student with the highest heart rate? Well, that's over here, that's 90 BPM. How many students had a heart rate greater than 86? So here's 86, and if I want to count greater, 1, 2, 3, 4, 5. 5 students had a heart rate greater than 86 BPM. Now all we're doing with these questions is learning how to read the dot plot, looking at the different ways that we can analyze the information. We talked about the lowest heart rate. We talked about the highest heart rate. We talked about a section of the heart rates. So hopefully what you're seeing are some different ways to describe the data on this chart. What fraction of students had a heart rate less than 82? Remembering that there were 22 students, and it's asking me for less than 22. That's 2 out of 22, or 1 out of 11. What heart rate occurred the most often? Well, we already discussed that. 83 BPM occurred more often than any other heart rate. What heart rate describes the center of the data? And here there are a variety of answers. We already kind of discussed this. I mean, we could say that it's 83 because that came up more than any other heart rate. We could describe the center as being kind of in this 84, 85 range because that visually looks kind of like the center. If we want to get really picky, maybe that even looks more like the center. So there are a whole bunch of different answers. The question is, can you explain and give a reason for your answer? Some students had heart rates that were unusual in that they were quite a bit higher or quite a bit lower than most other students' heart rates. What heart rates would you consider to be unusual? So now we're looking at the data and saying, as we look at this data, which is the data that just doesn't seem to fit or belong? Well, I feel like this one is kind of way out there all by itself. And I feel like maybe even these here are kind of away from everything else. I definitely feel like these top two, maybe kind of these top four here, I guess there's 5 in there, would be unusual. If I'm going to call this the center and want to kind of call that maybe normal, then these things are kind of out there on their own. Once again, we're not looking for a super precise mathematical answer. What we're looking for is some thinking here. Why would you consider them to be unusual? Compared to the rest of the data on the dot plot, compared to everything else that's here, what makes this one unusual? What makes this one unusual? Which ones would you consider to be unusual or why? It's kind of interesting to look at 80 and say 80 is unusual because no one was there. No one had that. So if Mia's teacher comes to you and says, what is the typical heart rate for 6th graders in the class? What would you tell the teacher? How would you describe what is typical or normal? And once again, it's not so much about having a correct answer right now as being able to say, I would say this because. And I would really lean towards probably just this middle section right here. We've got all of this stuff really close together. They've all got 2 or more. They're all right next to each other. They're all consecutive. They're right in the middle. I would really look at this and say, this is pretty typical, somewhere in this 82 to 86 range. And if somebody said, well, that's not big enough to be the middle, well, then I would look at the middle here. 84 and 85 is kind of the middle for me. So remember that Mia's heart rate was 80 BPM, and we're going to add a dot for Mia's heart rate to the dot plot. So Mia was at 80, and we will add that. So how does Mia's heart rate compare with the heart rates of the other students in the class? So we're looking at a point of data, and we're asking how does this point compare with everything else in the class? Well, I can make the statement that Mia's heart rate was lower than all but one student in the class. She had the second lowest heart rate of any students in the class. All right, example 2, seeing the spread in dot plots. Mia's class collected data to answer several other questions about her class. After collecting the data, they drew dot plots of their findings. One student collected data to answer the question, how many textbooks are in the desks or lockers of 6th graders? She made a dot plot. She didn't include her own data. Before looking at the dot plot, think to yourself, do you think the data responses will be similar, or will the data have a wide range? In other words, are we going to have a big variety of answers? Are we going to have a lot of variability? Are things going to be really spread out? Or are we going to have a pretty narrow range? Very few responses. Well, Here is the dot plot. Does this dot plot match your thinking? Are the responses similar? Why or why not? So as we look at this, we see that we have this variability. We range between 5 and 8. Was that closer together than you thought it was going to be? Or was it way more spread out than you thought it would be? What are some reasons that you can think of for why the data looks the way that it looks? Oh, let me back up there for a second. I'm not surprised by the data because as I thought about this question, I thought to myself, well, most students are going to have anywhere between 5 and 7 classes. Most of their classes are going to have a textbook, so I expect there to be textbooks for 5 to 7 classes. And so the data fits right nicely into that 5 to 7 range. I would have been very surprised if most of the kids only had one textbook, because in my head I counted that they'd have probably a reading textbook, a math textbook, a science textbook, math, reading, science, social studies textbook, and then there's always seems to be at least one other class that has a textbook. So in my head, 5 to 7 seems to fit pretty well. All right, another student in Mia's class poses the question, how tall are the 6th graders in our class? Would the data vary more than the data collected about textbooks? So this is our data about textbooks. Compared to data about height, is this data here about textbooks going to be more spread out or less spread out than data about height? And of course, this is where you'd want to pause and think about that for a second and make your prediction. So here is a dot plot for height. And as I look at this, it is very spread out by comparison to the number of textbooks and lockers. And honestly, I'm not surprised about that. With textbooks, we had 5, 6, 7, 8, because we have a certain number of classes we take every day. But when it comes to height, there's much greater variability. Some people are 49 inches. Some people are 65 inches. We have much greater variability, much greater opportunity for variability when we talk about how tall people are. So taking a look at the spread of these two dot plots, what are some things that we notice? Well, this one is spread out over 4 numbers, 5, 6, 7, and 8. This one is spread from 49 all the way up to 66, even though we do skip a couple of numbers in there. So I'm looking at the height here and saying, wow, that is really, really spread out by comparison. So taking a look, we're back on exercise 11 here. We've got a situation, and we are answering the question, which dot plot goes with the data that would answer this question? So if we were to ask, what are the ages of 4th graders in our school, which dot plot would give the answer to that question? Well, do I think that students in 4th grade are 58, 60, 61, 64, 66, and 73 years old? No, I don't think so. Do I think that students in 4th grade are 1-year-old, 2-year-old, and 3-year-old? No, I don't think so. Do I think that students in 4th grade are 0, 1, 2, 3, 4, 5, 6, 7, and 8 years old? No, I don't think so. Do I think that 4th graders in our school are 9 years old and 10 years old? Yes, yes I do. Dot plot A matches that situation. Exercise 12. Which dot plot shows data that would answer the question? What are the heights of the players on the 8th grade boys basketball team? Well, let's see. This could be 9 inches, 9 feet, 9 meters, 9 miles. But I really have a hard time believing that there are only 2 heights, so I'm really not thinking that that's going to work. 0, 1, 2... Once again, I'm having a hard time picturing this. 0 feet, 0 inches, 0 yards. I'm just not feeling it. We've got 1, 2, and 3. Once again, I'm 1 yard? 2 yards and 3 yards? Let's see, 3 yards is 9 feet. I don't know of anyone who's 9 feet tall. But as I look at plot D here, I could see these being basketball players. 58, 60, 61, 64, 66 as inches. So dot plot D. How many hours of TV do 6th graders in our class watch on a school night? Well, I'm feeling like 9 and 10 hours are probably not realistic if we were actually in school. I'm definitely feeling like these numbers do not make sense. I'm looking and thinking 1 hour, 2 hours, and 3 hours, not bad, but as I look at these other ones, some people don't watch any TV. Some people watch 1 and 2 hours, and then we've got those people who watch a whole lot more. So I'm really feeling like dot plot D would represent the number of TV hours. How many different languages do students in our class speak? Well, I'm really feeling like 9 and 10 are way out there. I'm feeling like even from 0 to 8, 0, they don't even speak English or a primary language. I'm not buying that one. I'm definitely thinking 58 through 73 doesn't make sense. But the vast majority of the students speaking one language, their first language, some of them speaking a second language, and then a few people who can speak a third language, that sounds realistic. All right, so here we are wrapping up the lesson. If a number occurs twice in a data set, how do you represent the second one on a dot plot? So if I've got a data set 1, 1, 2, how on a dot plot do I show that I had 1 twice? Well, I put another dot on top of it. Place a second dot on top of the first dot at the same value. When examining a dot plot, what information can one gather? Well, there is a wide range of stuff out there. We can find the smallest and the largest numbers. We can gather information about the spread of the data, how far is it spread out, and we can come up with a rough idea of what the center of the data, where the center of the data is located. All right, so if we were to give you a set of data at this point, hopefully you could construct a basic dot plot or line plot. Hopefully you could, in basic vocabulary, describe the distribution of the points on describe the distribution of the points. Hopefully you could talk about kind of where is the middle, the center, and hopefully you could also talk about the variability. What variety of responses do we have? So that concludes Module 6, Lesson 2. Make sure that you complete your problem sets, your exercises. If you've got questions, make sure you ask them.